I'm very happy to welcome Lukas. Lukas is the head of engineering at Suntrace. He's calling us from Germany. He's been the owner's engineer and EPPM project manager at the Fekola mine, and so he managed the entire engineering services there, as well as the engineering for the Noor Midelt 1 in Morocco. As you can see, I mean, his entire professional life has been devoted to solar, to battery system, to CSP technology. So he's really a great person to join the discussion today. And so without further ado, Lukas, very happy to welcome you today. I invite you to share your presentation and to join us and to turn on your camera so everybody can follow you and your presentation.
Thank you very much, John, for the kind introduction. It seems like the host need to enable me starting the video.
Absolutely. There you go.
All right. Thanks a lot. So let me start sharing my screen. Again, I think you need to enable me to share the screen.
That should work.
All right.
Yes, we're on.
Perfect. So again, thank you very much for the kind introduction. I'm very pleased to be here at the APSIA Storage Technology conference and to present this exciting project to you. I do intend to take a little deep dive into how we use the battery storage and how it has also been designed and what were the requirements for this particular project. So I think it's going to be an interesting session for you, and I hope you stay tuned to learn more about this project. First, let me also shed some light on our role. Suntrace is part of the Dornier Group, which is an infrastructure service provider, ranging from early stage engineering till construction, operation, and also throughout different fields. So it's not only renewables, but also water, mobility, and grid. And Suntrace, as part of the Dornier Group, is leading on the renewable energy side. We do act as an independent consultancy firm. So we are technology agnostic and basically team up with our clients to find the best solutions for them. For this, we do have a holistic approach, combining technology, financial, and also meteorological expertise for the solar, but also wind projects. And lately, we have a strong focus on C&I and in particular the mining industry because of the huge demand to decarbonize and also the very attractive business cases that arise from the lower cost renewable energies. But I will explain a little bit more about this shortly. All right, so let's have a look at the Fekola project. The Fekola gold mine from B2Gold is located in Western Africa in Mali, close to the border to Senegal. And Suntrace, together with BayWa, has developed a solar battery hybrid plant concept and was then contracted as the engineering and procurement contractor to B2Gold, whereas B2Gold basically managed the construction and which was then supervised by us to make sure that the solar and hybrid system specific expertise is available. And then we also continued our support for B2Gold during the early stage of operation and continue today. So the first phase, which was the concept development, started in early 2019. Also in parallel, we conducted a solar measurement campaign to make sure we have the right data on the actual solar irradiation and in particular also on the soiling. And then we came to a, let's say, very fast track implementation stage from finalization of the feasibility study in May to board decision and start of implementation in July. So that was quite quite a fast track. And the plant has been put into operation early last year and continues to operate well beyond expectations. I will also share some more information on the actual operation later. Okay, so in order to understand this project a little bit more in detail, I think it is worth to look at the actual requirements, because every mine is different and every project has different requirements. So in this case, it is an island grid operation, and there are existing HFO engines to supply a constant load of about 42 megas on a 24/7 basis. We do have two very important consumers, which is the ball and the SAG mill. Each of them has about 12 megawatt load. And so the whole system needs to obviously respect the requirements and the characteristics of the main loads to keep the grid stable at all times. Now, the new build system had, of course, the overall objective to allow stable and reliable power supply. This has the highest priority, and it also was designed accordingly to fulfill this objective. Some other requirements that are related to the engines are the system or the engines, they don't like to run in, let's say, a low load condition, or they also don't like to ramp up and down quickly. They also don't like to be switched on and off frequently. So we needed to consider a lot of, let's say, boundary conditions to make this a stable system. And also that the system would be convenient for operators to handle, respecting the also redundancy criteria. All right, so let's have a look at the concept that was implemented. So what we see is that there's basically the existing gensets, which was an existing power plant of a total capacity of 46 megas. Most of it is HFO based, which is 54, and the rest is diesel generated capacity. However, the diesel generators are not used for the normal power supply, only serve as a backup system. The load of approximately 42 megawatts requires constant power supply over 24 on a 24/7 basis, as I explained. And the optimal size that we came up with is a solar plant of 36 megawatt peak and 30 megawatt AC capacity. It's a single axis tracked system, and it includes a battery system of 15.4 megawatt hours and 17.3 megawatt of battery power. Now, it also includes a forecasting system that basically predicts the solar power to be expected on a day ahead basis. So focusing on the next, let's say, 12 hours. So operators in the morning have some idea on the generated dispatch schedule. What I would like to point out on this slide is, as you can see from the simplified diagram, the battery and the solar plant is really a combined system. So engines do not or never see only the solar plant, but it's always filtered through the battery. So battery has a chance to absorb power or to discharge power in addition to the solar power, which allows us to have a stable grid at the gensets or at the mine level. And the way this looks during a, let's say, clear sky operation, a typical day, is that you basically, with start of solar power production, ramp down some of the engines and then ultimately switch off engines one by one till you reach a generation at 3 engines. And during a clear sky day, the system allows to actually switch off all engines except for 3, and then ramp down those engines to allow up to 75% of the power to be provided from solar. So this was, let's say, the concept idea nowadays we often run even at 2 engines because sometimes load is a little bit less, or sometimes you have a very good clear sky day, which allows you to, let's say, take some more risk on engine operation. All right, so what happens when, let's say, the day continues and there's a little spike in the solar? Then basically the battery comes in and absorbs or provides the required energy to keep the engines within the operating ranges. And this happens all the time. So the battery is really there to basically allow this high penetration of renewables in the system, and yeah, respect not only the engine loads, but also the consumer requirements, the mill, the ball and the signal. Some other project features I believe are very interesting is that this system allows to save about 13.1 million liters HFO annually, which eliminates 39 kilotons of CO2 emissions per year. And what I mentioned earlier about the business case for these off-grid systems, the project has a very attractive payback time of 4 to 5 years. All right, so you might wonder, okay, this clear sky day looks very nice, but how do you actually operate? Sorry. How do you actually operate on a cloudy day? So I would like to also share this example with you. So from operator perspective, on a cloudy day, you need to know how you can dispatch the engines, whether or not you need to start or stop an engine. And this is really where the solar forecasting comes in and helps you to run your dispatch schedule and to have some good idea about the weather conditions to be expected. And the forecasting system is not only satellite based, it's a combination of satellite and numerical weather predictions, but we also have a sky camera that assesses, let's say, clouds that maybe were missed by the satellite based forecast. So it allows operators to receive warnings in order to start an engine in time. I would like to point out that even with the forecasting system, the battery is still your backup system. So even if you miss to start an engine, the battery will still cover you and provide the power you need to keep the engines online. Sorry, not the engines, but to serve the load and to basically run the system in a stable conditions. And this cloudy day, this is another example how it looks like. You see lots of spikes, and let me just quickly explain how you need to read this graph. I think it's worth the time. So the red line represents the load for the gensets, so what they need to provide, whereas the yellow fill obviously is the solar, and the light yellow spikes that are repeated on top of the load, this is where the battery comes in and absorbs energy or delivers energy to the system to keep it in a stable operation. The blue dotted line refers to the engine spinning reserve that is left in the system. And this is actually where the battery really adds the value, because the battery in such a system, you need to consider it as a spinning reserve replacement. So it enables you to even have a high penetration of solar power. The battery in this system does not provide load shifting. So you don't charge it during the day and then discharge in the evening. That's not the purpose. The battery is really a safety backup for you and serves as a spinning reserve replacement. Besides the smoothing of the solar fluctuations, it also curtails the ramp events, as I mentioned. And it all of the time provides also primary response and primary services to keep the grid stable. And I would like to also share an example on how this works in the next slide. And what you can see are two events that actually occurred. So these are measured data from the energy management system. And it shows you the grid stabilization services for, first of all, a mill trip on the left side. So let's have a look at this. You will notice that the load goes down from about 30 megas to 22. So you lose a lot of load in a very short time. Now, in order to keep the frequency stable, the battery needs to absorb power from the solar plant, which is shown on the very bottom graph, because the solar plant inverters are not able to ramp down in such a short time period. So the battery really enables to keep the frequency within the required bandwidth and keeps the system stable. On the other hand, when we look at the right side, we see a genset trip during nighttime where there's actually no solar. And I took this example because obviously the battery also provides services when the solar plant is not operational to improve the overall grid stability. And in this case, there's an engine trip, and the remaining engines are at a very, let's say, high load. They run at about 90% or 95%. So they will not cover, or they should not cover, this load because they would be overloaded for a short period. So the battery again jumps in, provides primary response, and discharges power to fill the gap. And so you have, or the operators have, sufficient time to start an engine and run or go back to normal operation. All right. So in summary, I think we can say that this case where we have about 20% of fuel savings or 20% of the overall power supply provided from solar and the battery is a proven case. And the Fekola project continues to exceed expectations. And I would like to point out that with the current energy prices, amortization might be even faster than expected. Worth mentioning is that operational benefits from the battery continues also throughout the night time and improve the grid stability, and also, for instance, avoid load shedding at engine or mill trips. Another point I would like to mention on actual plant operation is when you start up a mill, you need to supply a certain amount of inrush current for the mill drive, the mill motor. And usually you need to have your engines ready in a low load situation, waiting for the mill to start to supply the inrush current that is needed. And here the battery system can really supply or support this process and allow you to run with less engines during the startup of the mill, keeping them in more favorable load conditions. So this is another benefit. I didn't have time to put a respective graph, but I think it's worth mentioning. All right. Besides this, the Fekola solar power project is actually also able to run in a solar-only mode, which can be used during downtime, for instance. And there are, of course, also some other limitations due to HFO heating and others. I think operators will know that needs to be respected. But in principle, this is a possible situation. Okay, other improvements are the reduced genset running hours and the reduced maintenance, which helps to save some additional money with such a system. All right. Let me just quickly point out that we have a very strong footprint in Africa, and we have also been recognized by the FCA Technical Advisory Award in 2020, which was a very very rewarding recognition from the market. So thanks for this. And we're happy to provide or continue to provide our independent and client-oriented renewable experience for your projects. All right, my key takeaways from this presentation are basically that these kind of systems will become the new normal for the off-grid situation in particular, because it's a very promising business case. And reaching 20% fuel savings is a proven case as well. The battery is key for the reliable operation. And in this case, as I mentioned, it is really considered as a spinning reserve replacement. And I would also like to mention that the 20% we see today is only the first step. And you can, of course, have a higher solar penetration to reach even higher renewable energy shares, but you could also combine it with wind in such a system to exploit the full potential of the renewable energy source. And with this, I come to the end of my presentation, and I'm looking forward to receive your questions. Thank you very much.
Thank you, Lukas. Very impressive work done there. And definitely interesting, because many of us here, like solar professionals, we've long been advocating about the benefits of solar for the mining sector. This is a landmark project which has taken quite some time to put together, has been in operation for some time as well. And in recent months, we've seen a few announcements of more mines going solar. So this is very encouraging, and I'm sure many people will have been inspired by your work there in Mali, and will be getting in touch, if not already, about getting more knowledge on how to optimize their operations. We do have questions, very specific questions. Tony is wondering, how was the LCOE before and after? And as an additional question, have you been able to measure exactly the impact on the O&M, and what kind of costs this represents in total?
Yes, good questions. And so there are different numbers on the LCOE, but if we look at only the energy supply with such a system, you can lower the cost, let's say, by about 2 to 3 cents in total. So I'm meaning the overall cost for electricity, including HFO engines. So this offers, of course, a very good opportunity. If you go even further, if you increase the renewable energy share, obviously you can also further lower your electricity cost for such a system. All right, and the second question related to the O&M, I can say that yes, this of course has been considered. You have some, let's say, advantages, but also some disadvantages by running engines in such a mode. So they balance out, and the advantages supersede finally. We did consider, and this has also been, let's say, confirmed in actual operation of the plant. I hope this answers the question. I'm afraid I'm not able to share exact figures, but in principle, yes.
Fair enough. Next question from Luca. So you've been sharing several numbers, like solar penetration goes up to 75% at times, overall fuel saving 20%. But Luca is wondering, in the end, what is the PV penetration year round on the total operation of the mine?
Yes. So from all the electricity that needs to be supplied to the mine, 20% comes from the solar and the renewable energy plant, including the battery. This translates into some 63 gigawatt hours per year.
And as an additional question to this, a question from John, not me, but another John. He's wondering, this seems like to be a lot of work for only 20%. How can you get to more? Why did you not get to more yet?
Yes. So first of all, I believe the work you put in pays back pretty quickly. So the savings speak for themselves. And as I mentioned, it is a first stage. And for these kind of systems, also in other projects that we see or being announced currently around the world, we believe this will be only the first step, and you go bigger. Why you do it in a stage-wise approach has also something to do with if you think about how much money is lost if your electricity supply doesn't work for one day, meaning the mining operations, then you get a sense of the scale we are talking about. So mining has always highest priority, and you want to be sure you build up your system reliably and safe, and you build up confidence and trust in renewable energy power supply.
But yet you managed to build a system where at the peak, 75% of the power generation comes from solar. If I'm not mistaken, this is significantly higher than a lot of the electricity systems, even the most developed ones. How would you say this compares? Of course, this is an island project, but yet, I mean, we're talking about 42 megawatts at any point in time. Is this a message maybe to grid operators that they should, you know, very often you hear that, oh, solar is unstable, we need to allow only a certain level. In your case, 75% seems to be absolutely doable.
Yes, and the advantage, of course, that we have in the mini grid application is we are able to simply switch off some of the engines, and operators actually want to switch them off. So there's not this, let's say, natural conflict of interest that you might face in a grid connected situation. In a grid connected situation, I also would like to point out that you may not need the battery, maybe not in such a scale that as we have it for a mini grid. So grid connected is always a very different story. And I'm saying you may not need a battery if you look at it from a pure a solar or wind project perspective. But obviously, to reach high penetration or high share in the system, you again need a battery. Yes.
Talking about the battery specifically, so if I followed correctly, the storage has two main functions in your project, smoothing the solar, but also stabilizing the grid. So that means, if I'm correct, there's a lot of back and forth input and output from the storage. Does this have some kind of impact on the longevity, on the number of cycles that are being considered from this storage? This is not the typical I charge all day and then I discharge at night. How should people look at this specific situation here?
Yes. So the battery, if you have a very good clear sky day, is actually not used at all because it is not needed. If operators follow the forecast and the dispatch schedule, they have always sufficient engine capacity online. And if the ramps are not too steep, the battery will not kick in, right? When you have, for instance, a cloudy day, the battery obviously needs to absorb and put back a lot of the energy. And in your, let's say, daily overview graph, it seems like it has been used a lot. But when you translate this into cycles per day, you never reach one cycle per day. You are more at half a cycle per day even on a cloudy day. So this has all been considered in the sizing, and the battery is sized accordingly. So it has the same, it still supplies the safety measure it is designed for at the end of the life of mine, right? So it's from day one designed in a way that it will last throughout the entire operational period.
Fair enough. And talking about the design, we have a question from Leopold, and that will be the last question we will take today because we're already slightly over time. There are more questions, but as I said, we will share them with you, and then you can follow up with the different listeners. Leopold was wondering, like, how did you design and size the battery to start off with? Did you say, to be on the safe side, we want to have maximum 20% and that will be safe? Or was there other considerations taken into account? That's question number one. And question number two, how far are you going to go, ideally?
All right. So first on the battery sizing, the battery sizing is always very project specific, and it considers lots of different, let's say, scenarios where the battery would need to jump in and save the grid, basically. So this could be tripping of one of the main consumers. We also analyzed the maximum fluctuation of renewable to be expected at this specific location. So this also comes as one of these scenarios. And you put this all together and then you figure out a minimum size of the battery that you need in terms of power, but also in terms of capacity. And then you go to the market and you ask, what can you provide? And so most likely you end up with a different size in terms of power and capacity, but it always must fulfill your minimum requirements. So, and I have to admit, I'm not entirely sure what was meant by how far can you go ideally.
What is your ambition with this project? Can you go to 60%? Can you go to 80%? Can you go to 100% maybe?
Okay. Yes, I mean, for me as the advisor or the consultant to be to gold, we would of course like to continue with, let's say, possible phase 2 or increase the renewable energy share. And I believe there are different options. If you include wind energy, for instance, the highest share that you can reach will be significantly higher. So we talk about maybe 60 to 80% of renewable energy share. Beyond, you have to check if it will still be a, let's say, improvement of your electricity cost. And in this particular case, the life of mine would be one of the concerns. However, if you build, or if you are to build a new mine, or if your life of mine expectations are, let's say, more than 15, 20 years maybe, then you can certainly also reach 100%. But you would need to combine different storage technologies. Then it won't be only a lithium-ion based battery.
Fair enough. Well, thank you so much, Lukas, for sharing such a great insights and about a very exciting project. It's really always a pleasure to have you guys. And yes, I think this award that you got, not given by AVSIA, by the way, but by the jury, is well deserved. And I look forward to you guys continuing the good work on different projects. I will close now just in a few minutes. So for anybody who has a few more questions, this is the time to drop them in the Q&A section. But just the last few comments before I let everybody go is I would like to let you know about some upcoming events. If you liked today's event, well, hopefully you liked the next one. As you know, we have a very good partnership with Startup Energy. We organize startup camps, and we also like to promote some very, very interesting African energy startups. The next time we will do so is through a webinar on May 24th. So I hope you will be able to join and get to meet some of the laureates of the second bootcamp that was organized in April. We also have the Solar Awards coming up in June, on the 23rd of June. This will be taking place during and in collaboration with the Africa Energy Forum, which I'm sure you're all familiar with. It will be a live event, and if you want to get a chance, just like Lukas and Suntrace, to also be recognized for your great work, applications are still open until May 13th. And we have 13 categories in competition this year. And then finally, also by the end of September, a little bit further from now, we are organizing the first Africa Renewables Investment Summits in Cape Town, really meant to be like a platform for all developers and all financiers to meet in one location, discuss their projects in Africa, make some partnerships and move to the next stage with their project. So we hope to be seeing you there as well.